Okay, now there is sound. Oh my, this happened to me all the time. I don't know what am I doing. No sound for 5 minutes. Incredible. Oh, no sound for 2 minutes. Okay, it's not so bad. Thank you. Good morning, Pablo to Spain. So, okay, let me start over then. So welcome to Star Talk Show, and today is September 27th, Friday, 2019, 9 o'clock a.m. San Francisco time. And today, Pablo, if you have a question or topic, just type it, okay? And today I have prepared several things very interesting. We're gonna talk about sleep dream inception. I have a experimentation with sleeping schedules. They say that some genius such as Leonardo da Vinci, he or some other genius, they have special sleeping schedules. Supposedly some of them sleep only 4 hours a day or something like that. And I'm going to tell you my story. I haven't slept yet, by the way, so I'm going to sleep after the talk. And we're gonna talk about, okay, so sleeping schedule, and we're gonna talk about network anthropology, tales of tech geekers, a net ethology, or a troll's confection. Now note, this is confection, not confession, okay? A troll's confection. And this would be fun. This collection of articles would be my story of being a troll, so to speak. Okay, I don't think of myself as a troll. I despise that concept. Troll. Most the Unix hacker types, yeah, they have a picture of the troll. They think of someone who is just trying to disrupt things and things like that. Also, we can talk about the history of the word troll. The meaning of troll changed over the past 3 decades. Okay, yeah, more or less in every 10 years the meaning changed. So today is like almost like anyone is a troll. So we can talk about the history of the word troll. And anyway, so on this page is a collection of my articles on that topic. A lot of people, especially in the 2000s, uh, you know, 2000s, Lisp programmers, Common Lisp in particular, programmers, Perl programmers, Python programmers, they have called me a troll. So I have a lot of stories to tell, and in some of them, and also I discuss network. In some of these articles, I discuss the meaning of troll, and some of the articles I discuss network. Network is a popular jargon back then. Today you don't hear it much anymore. And I discuss many of the typical mindset of these people. These nerds, these programmers. They are many of them are vicious. So that's about this page. And we're gonna talk about new Lisp. So someone made a comment, asked me a question about new Lisp. This is new Lisp is a scripting language that's very interesting. So we're gonna talk about that and some other more topics. Kinesis laptop, that's interesting. That's like that. Okay, so well, instead of just showing you what we're gonna talk about, why don't we begin? Oh, I got $180 a month right now. Thank you guys. So I want to thank you my uh, patrons. Yes, thank you guys for the patronage. $180, good. Okay, so let's see what we have comments and who is here. So Pablo's no questions, no topics. Okay, good morning, Green Deck. Uh, Good and bad syntax. Okay, that is going to take one entire hour, more than an hour. So If we talk about that, maybe should we? Maybe we should talk about that because since you asked, so nicely and so early. But otherwise, I was going to talk about these other things. So let's look at the So syntax. What is a good syntax? What is a bad syntax? And for that, we go to this section, which is a index of articles all about syntax. Now, by the way, so this is a funny picture. Someone posted on Twitter. It came from Twitter a few years ago. This. So you are in Russia, right? Good morning to Russia, Green Deck. But this is in America. So this is a bookstore, and you see they have a section on computer science, and the books are Facebook for Dummies, Spotify for Dummies, WordPress for Dummies, Pinterest for Dummies. these are these are computer science for the general population. So anyway, we're gonna talk about if the syntax. If we talk about syntax, that's gonna be the whole day. That's gonna be like the several hours about syntax. So maybe we pick some specific topic because I have like the 30 articles on syntax, just on syntax alone. In fact, okay, yeah. Since I'm talking about this subject, I look at the articles. I have like tons of things to say. Like there's this fire burning. I just want to talk about them. Uh, Formal definition of systematic grammar. Yes, that's a So I this subject I really want to tell you about. Uh, there are quite a lot. So we have to like pick something, a thing or two. So if you have Green Deck or anyone, if you have some particular things you see, we can talk about that first because usually otherwise I start with a topic and you just on and on about that. Yeah. So all these, for example, the first six articles are related to systematic grammar. Okay, when we talk about syntax, we typically like C++, Java, Perl, almost all languages, okay, including Haskell, meta language, OCAML, Fsharp, C#, Python, Ruby, okay, all these languages, APL and Julia, okay, all their syntax is like one time syntax. In general, they are not systematic. That is, they are just random, almost random. Like you for example, if I'm you know why C syntax is bad. Okay, I'm gonna tell you that. Okay, Pablo says I'm okay with your topic for today. Okay, so there's me. So let me finish this. I was talking about systematic grammar. Okay, I was talking about so all these languages, basically all languages we know, industrial languages, they their syntax is whatever the designer just created one time. For example, I'm going to create a language, and I just created just by my preferences, just by whatever my thought. It's almost always, it's never well thought. Okay, for example, C syntax. Now I don't know the detail. I don't know the detailed history of C syntax, but I think it came from the language B. Okay, there's a language B before C. Um, I think it came from Argo. Argo. There's a language called Argo. Okay, it's ALGO. Okay, so that let me magnify ALGO. Okay, so let's see Wikipedia. Let's see Argo. Uh, there it is. Argo is an algebraic programming language developed between 1959 and 1961. Let's see what Argo syntax looks like. I haven't seen it before. Okay, that's not that this syntax is like basic. Yeah, this so this so anyway, so C, I think I don't know the detailed history of where C syntax came from, but I think it came from B. There's a language named B. Okay, but basically, I mean, if you look at the C syntax, okay, it's just ad hoc. They say ad hoc, meaning that you just create you just create one out of the blue. There's really no logical reason. I mean, it's not really thought out. It just happens. So just like Emacs key binding, Vim's key binding, just almost just like everything else, like the keyboard layout, the QWERTY keyboard layout. It just happens. We need to do it. You just create one. So it just happens on the spot. It really there's no it's not like from a systematic study of syntax then you create one. It's not like that. And speaking of C syntax, why is it bad? Let me tell you why is it bad. Okay, so why is C syntax bad? It's first of all it's ad hoc. Okay, it's oh wait, hold on a second. Before we go, let me finish the previous thought. Okay, so I was saying all these languages, their syntax is just one-time design. Whoever designed it just not systematic, not it's not after 5 years study of or possible syntax, then you create one. It's not like that. Most of all these languages, they just happens. Like for example, it includes Python syntax came from there's a language before Python. The Guido van Rossum who created Python. He created Python because he was used to the other language. Do you guys remember what's the history of Python? What's the other language that Python came from? There's a language. I think it's called ABC. Am I correct? You can easily look up Wikipedia and you will find the answer. But Python is based from another language, Guido van Rossum, the stupid guy. Okay, Ruby syntax, for example, Ruby syntax came from mostly Perl. Ruby is supposed to be an improvement of Perl. Ruby is a mix of Perl and Lisp, in particular Emacs Lisp. Okay, I have so many articles I want to show you. It's like I have so many topics right now. I'm gonna blow up. And so we need to write it down actually because otherwise we so let's write it down then. Okay, let me talk about systematic syntax. Most languages syntax are just odd, ad hoc, no design whatsoever. Talk about okay some language syntax can from design such as APL. Now APL is a language whose syntax came from really thoughtful design. Now you guys probably haven't seen APL, right? So maybe I need to show it. I have so many topics right now. So APL, yeah. So today is gonna be a long talk. I can't use too many topics. APL. So some languages syntax came from design, such as APL, and what's and APL and others. Let me come back to that. Okay. Then we have systematic syntax system. Okay. Then we have this thing called syntax system. For example, Mathematica. Now Mathematica syntax, first of all, It came from Lisp, kind of, okay. But however, it's rather very different. But the point I want to say is that it's a system. Uh, it's a syntax system. We'll have to explain that, okay. So most languages syntax are just ad hoc, no design whatsoever. Some languages came from design, such as APL and the Lisp. Okay, we can count Lisp here, and and Haskell. Okay, Haskell, OCAML, ML, um, Fsharp. Okay, um, for example, APL. So let's cover the subject one by one. So we keep on track. OCaml, ML stand for meta language. Okay, F sharp. OCaml, ML, F sharp. They are basically the same language family. Okay, F sharp is Microsoft's version. Now Haskell. Um, okay, so let me talk about that. So first of all, let me show you APL. Okay, then we're gonna talk about why C syntax sucks. Show the article why I hate C. Okay, I'm gonna show that article in order to talk about that why C syntax sucks. Okay, then we're gonna talk about what is a good syntax, what's a bad syntax, how do you judge things like that. Um, okay, that's that we're gonna follow those topics. So Bostiat says, how do I remap the keys in Ubuntu so that in every input box I can use bash shortcuts? macOS, uh, how do I remap keys in Ubuntu so that in every input box I can use bash shortcuts? In every input box. Okay, you mean like everywhere, like also in browsers and everywhere, right? Uh, right. So how do you do that on Linux? In everywhere, you want basically you want the bash or Emacs, basic Emacs set of keys. Um, I don't know offhand. I have to look into. Let me show you the articles. Maybe we can find it later. But okay, so you can so in order to do that, you want to have press control something, control A, for example. Control A goes to beginning of line. Yeah, I have some suggestions I can tell you, but I'm not sure it'll work for you. Because for example, okay, let's go to Linux keys. Okay, so you go to just search for Xali Linux key binding. You will find this page, and what you want to do basically, what you want to do, the kind of key binding you want is that you want control something like control A, then you want to bind that to a command. Okay, that's a type of the key binding you want to do. And in order to do that, you need to use uh, let's see, is it xbind keys? Yes, I think that's one you want to try. So download, read this page, expand keys. Okay, I have not tried what you want to do. By the way, I don't think that's a good idea. Okay, I think it's a terrible idea. Basically, what you want to do is basically you want Emacs keys everywhere. That's a terrible idea. You're gonna get, first of all, it's very inefficient. Okay, it's very inefficient, meaning that your hand has to bend into weird shape or move around more than necessary to do what you want. So also that also means you're gonna get repetitive strain injury, okay, faster than if you don't do that. So I don't recommend that. So, but if you really want to do it, I recommend look into expand keys. In fact, let's look at this one. In fact, since a key. Okay. Yeah. Look at these articles. The expand keys. Look at expand keys and XVKBD. But actually, I would recommend you just go to one of the Linux forum and ask them. They will, because this is a frequently asked question. A lot of people will want, they would want to have Emacs keys throughout Linux. So you go to one of those forums. I'm pretty sure someone has, already have a specific set of instructions or a tool that you can just install. So do that, okay? Now let's go back to the syntax. Let's go back to talking about syntax. Okay, good morning, Bartholomew. Bartholomew, I'm on the phone, so sometimes the connection will drop. Okay. Good morning, Derek. Uh, Boss Tia says, I just want what Mac OS has. Don't you use the shortcut Emacs? No, I don't. I never ever use Emacs key bindings. I'm telling you, like I'm telling you, I'm gonna tell you one more time. Don't do that. Okay, do not use Emacs key bindings at all. I mean, if you use Emacs, change them. Do not do not use any code combination. Do not ever, if you can, avoid any like rip out the control key on your keyboard. Rip it out. Rip out the old key, control alt, the Windows key. Rip them out. Okay. I have, like, just search for Xali uh, key code, like band key code. Okay, you go to my keyboard blog, you will find the article. Okay, let's not talk about that today. I did a video 2 days ago, if on key bindings on keyboards, or that. So you might check that out. So I don't recommend it. Don't do it. Uh, good morning, Matt. So today we are talking about the syntax issues. There's a lot to talk about. So let's get back to that. So most languages syntax are just ad hoc, no design whatsoever. Okay, and that applies to okay, and some languages syntax came from design, such as APL, Lisp, Haskell, OCAML. Okay, let's start to talk about that. So APL, if you don't know what APL language is, let me show you. Okay, welcome to APL. APL Wikipedia there. APL stands for a programming language. I mean, it's a weird name, but that's what it stands for. It's a math-oriented programming language, and it's also a, what do you call, array. Uh, do they say here array language? Okay, array, yeah, array language. The paradigm is array, like Mathematica. Okay, it's a math-oriented programming language. So APL language, I just want to show you the syntax. Okay, the syntax of APL. In fact, actually, let's go to Xali APL. Okay, because I have examples and I have I have a number of articles about APL. Okay, we have two articles here, and APL code. Okay, there, three articles. So first of all, APL. Now, first of all, let me show you this page. This is the Unicode Apl symbols. Now, you see APL, the language. These are the symbols it uses for the source code of APL. So it's not ASCII. It's very, it's this APL is very well known for this. You got all these math symbols. So this is the APL symbols. Okay, and this is the original keyboard for the APL that supports the APL language. So this is IBM 2741. It's called teletype, I think, back then. It's not even a terminal. So anyway, now you know the name IBM 2741. You can look up on Wikipedia. So this is the original keyboard for APL, and APL began in what year? 1966. Okay, very old. It's like about the same age as Lisp. So anyway, that's APL. And in this article, I show you, if you are coding APL, I show you how to program your keyboard so that you have the APL layout. First of all, you need to get Unicode font. Then I show you how to do it on the Mac, on Windows, on Emacs, and and also you can buy this keyboard that has the APL symbols on the keys. Okay, and also you can buy keycaps so that for example, let me so I showed you that APL symbols, they are Unicode. Okay, they are these Unicode. APL keyboard, and you can buy the keycaps. Okay, if you buy a mechanical keyboard with the Cherry MX switches, then you can buy a special set of keycaps so that you can just plug them in. So your keyboard will have APL symbols. Some of them looks pretty good. Actually, I can show you. But we have a lot of topics to talk about. So I mean, guys, if you have any questions, you want to stop me, or you want me to go on faster, just let me know. Okay. So we already talked about 30 minutes. We haven't begun talking about syntax yet. So APL language. Okay. So that's APL language. Now my point about APL language is designed by this guy, Kenneth E. Iverson. Now, he spent significant time to study syntax. So eventually, he created APL, and the APL syntax, is invented by him. So the APL syntax is out. It came out from design. He spent significant time to design the APL language syntax. APL language syntax came from dedicated design. Unlike C, okay, C is the extreme opposite. No thinking at all. You know, so APL language. So we talked about APL. Then let's see what's the next topic. So some languages syntax came from design, such as APL. Lisp, as you know, Lisp too. Lisp is almost uniform parentheses, nested parentheses. So it came from the Lisp guy. So that is also by design. He thought about it, and he by design. Now the Haskell or CAML, ML meta language, Fsharp, those family of languages, their syntax also came from design, but it's actually the most idiotic. Let me show you the article about that. Haskell, this article, the garbage truck just passed by. So anyway, this article, okay, the most idiotic article. The article, this article is written. This article is written in. My God, the garbage truck is very loud. Um, do you guys hear it? Um, Shit. Okay, I'm waiting for the garbage truck to go away. Okay, it's gone, almost. So you said you didn't. I mean, you like the Haskell. Okay, so you like the Haskell. Okay, this is just my personal opinion. I don't like the Haskell syntax at all. I think it sucks. But anyway, let me tell you what's the origin of the OCAML syntax. Haskell syntax kind of borrowed from OCAML. Okay, now where does the Haskell syntax came from? Let me tell you the history. Okay, originally the Haskell people, Haskell is created by a bunch of academics. Okay, professors, who are studying functional programming languages. So because the functional programming language is a kind of common concept among professors who study languages, so they are thinking, let's get together and create a language together. So we have one unified functional programming language. That was the origin of Haskell. But originally they want the syntax to be based on Miranda. There is a functional programming language in commercial. Okay, it's a commercial functional programming language, not free. You have to pay or something to use it. It's called Miranda. Okay, let me type it. Haskell syntax originally wanted to be based on Miranda. Okay, there's a language called Miranda. If you search Wikipedia, you'll find it. Search for Miranda language. Okay, yeah, it's not there. Okay, but anyway, so they talked to the creators of Miranda, because there's copyright stuff like that, and the Miranda guy turned it down, refused, declined. So, so the Haskell people borrowed their syntax from OCaml. OCaml, okay. So again, okay, I talked about this many times. In the beginning, you have the meta language, okay, ML. You can look up Wikipedia. ML stands for meta language, okay. There is this language called ML. Then you have variations. Standard ML, which is SML, or then CAML. Okay, then you got OCaml. Okay, then you got Fsharp. Fsharp is from Microsoft, the latest variation. Microsoft about 10 years ago created Fsharp. So all these languages, ML, standard ML, CAML or CAML, Fsharp, they are basically the same language, little variations. So ML, the syntax, so Haskell eventually borrowed the syntax of Haskell came from ML. Okay, but where does the ML language syntax came from? It came from this article, this idiotic article. The article title is "The Next 700 Programming Languages." Okay, and this is the origin of idiocy of OCaml and Haskell syntax. One man's quirk. I swing. Okay, the article title is called "The Next 700 Programming Languages." It's a clickbait. This is a clickbait back in what year is this? 1966. Oh my God. So you see the history here. Here is the lineage of OCaml syntax. So you have this article. This article is known as ISWIM. Okay, ISWIM. Uh, why is it called that? Because I forgot. If you read this article, you'll know. Okay, so it's called ISWIM. ISWIM. I think it stands for I I do not understand something. Is kind of pun. I forgot. But anyway, this article is known as ISWIM. So this article is written in 1966. Then the language ML began in 1973. OCaml, CAML in 1985. Then OCaml in 1996. Then Fsharp in 2007, something like that. Okay, so the syntax of ML came from this article, and this article is the most asinine. You can read it. It's a PDF. Uh, okay, I got details here. Oh yeah, it's a PDF. Okay, you can read it. It's a PDF article. The next 700 programming languages by this guy PJ Landon. I think in 1966. I think he is. I'm not sure who exactly he is. I think. But anyway, he seems to be a hot shot at the time. Like today's hacker news. Some articles becomes hugely popular and everyone is retweeting it. Things like that. So back then in 1966, somehow his article, the next 700 programming languages, becomes widely popular. That is why the ML adopted this syntax. And I read this article. This article is very difficult to read, okay, and it's badly written in my opinion. The writing style it's hard to understand. Yeah, not because the subject matter is hard to understand, but rather because it's bad writing. That, in my opinion, it's a lousy, stupid writing style. So that so I don't like it. I because when I try to learn OCaml, okay, and OCaml and Haskell, I realized I don't like the syntax at all. Like who the fuck invented it? So so I looked up, I studied, I traced to the history. Then it came from this fucking idiot. Um, so it's a so you can call this a meme. This is 1966 meme of the 1966 or gun viral. You know. So anyway, but however, at least this syntax is not out of the whim. It's not a just a ad hoc. This article, at least it has systematic thought about how syntax should be. This guy, he's trying to think about. What he is thinking. The title, next 700 programming languages. What he's thinking is that he tried to, think of all possible syntax. However it may be. Like he's thinking for the next 700 programming languages. So in his mind, he's going to create, of all possibilities. He's trying to think of what would be the best syntax, out of all possibilities. So it's very ambitious, but it came out shit, in my opinion. So anyway, at least the ML language or CAML, F sharp, they came from a design. Okay, this is opposed to C fuck. Um, okay, so that is about that. So we finished talking about APL, Lisp, Haskell, CAML. These languages came from design, their syntax. Okay. Now Mathematica. Now, as I mentioned before, vast majority of languages, including this APL, Lisp, Haskell, their syntax doesn't matter if it's ad hoc or from design. Even from design, still it's just like a one-time syntax. There's no system. There's no grammar to it. I mean, not grammar is not the right word. There is no in other words, let me put it this way: you cannot, every syntax, every programming language has a, syntax, right? And every programming language syntax has a grammar, okay, to specify the syntax. But the grammar is ad hoc, okay. So their grammar is like so. So what is a systematic syntax? A systematic syntax is such that the grammar of the syntax has a grammar itself. Okay, that is Mathematica. In fact, I can show you many examples in my articles here. Syntax soup. Uh, Here's a lisp. Um, yeah, formal. Okay, so a year ago, 2 years ago, I realized a formal definition of systematic grammar, and uh, I talk about that. Hold on a second. Let me see if I. Okay, let's talk about systematic grammar. Okay, so let's talk about this article. So systematic grammar. Okay, I'm not going to read the whole thing. You can read it offline. Just find my article. You'll find it. Just search the title, Xali and the title. Basically, a systematic grammar is basically a grammar, the grammar of the syntax, such that the grammar spec itself has a grammar and a simple one. First of all, the syntax must be regular, okay, like Lisp. For example, Lisp, right? Lisp is basically almost, not 100%, but almost purely nested parentheses. So it's in a sense uniform or regular. So first of all, you should have that. Then, then I'm not sure how to explain this. Then you see the problem with hold on a second. I'm not sure how do I go about this. Let me check the comments. So if you designed a programming language, what would it look like? I have some sketches, but that let's talk about that some other day because it's gonna be too much to talk about. Nice clickbait, yeah. Maybe I just like to. Okay, so let's continue with the syntax. Um, systematic grammar. Okay, so let me tell you what how do I explain this? Okay, here is what I want to say about these. This is I consider okay. This what I am about to explain is basically Mathematica syntax, not just Mathematica syntax, but the syntax system, the systematic grammar of Mathematica. It's a system. Okay. So first of all, why do we need that? First of all, my personal preference is that I do not want ad hoc syntax. Actually, let's explain C first. Let's explain why C syntax sucks. Okay, let's explain that first. Let's go to semantic noodle. Then let's search for C. Okay, not here. Syntax soup. C. Okay, so syntax soup on Lisp. No, not on Lisp. Syntax soup. Semantic syntax soup. Semantic noodle. There is an article here. Why I hate C. There. Okay. So let's look at C syntax. Why is it bad? In my opinion, okay, my own preferences, I hate it so bad because it's ad hoc. Basically that word captures why I hate C syntax, because there is no it's not systematic. Like every command, every statement, you have to learn a new syntax. For example, you have I plus I, you have for, for loop. For loop is a very complicated syntax. Some part of it you can omit, some part of it you cannot. Then you have while loop. Then you have the braces. The braces usually makes a code block. Then you have this ternary expression. You know about this ternary expression, like it's a if expression. Expression question mark expression 2, then colon expression 3. That's a if expression. Then you have print or sprint. That's the worst example. Okay, so let's talk about the sprint statement. Yeah, are you guys familiar with that? If you know C, you know, or C++ or Perl. The sprint syntax basically is borrowed to every language. They are in Perl, in C++, in Golang, I think in Java too, in Python. So this is why I hate C. C and Unix, they are fuck. They are worse and better. They are the worst possible. But because it's so popular, it's free beer. So it becomes, it goes to C++, it goes to everywhere. So every language now today inherited the sprint, the command, the function, the subroutine sprint. So why is it bad? Because if you look at sprint, like you know what I'm talking about, right? For example, even in Emacs Lisp, let me show you. So describe function format, okay. So you see, this is what you get. You get this bunch of percentage shortcuts, kind of cryptic thing. Percentage S for string, percentage D for signed number, percentage O for octal notation, percentage X, so on and so on. And then you have formatting float. Then you have this extremely hard to understand, impossible to understand. Now, if you code in any of this language involving format or string, you know what I'm talking about. So it's almost just for this single subroutine string sprint, it becomes a mini language by itself. Like, you know, so that's my point about C syntax. It's not regular. In fact, it's the extreme opposite of regularity. Like every function has its own special syntax. I don't like that. I hate it. Okay, what I like is, first of all, regularity, no exceptions, such as Lisp syntax. That's one of the example. What are others? Others are examples such as APL. Okay, we talked about APL. Oh, but I forgot to show the code. So here is an example of APL code. Here's the example of APL source code. Okay, let's magnify. Okay, here is a example of an APL source code. And this is actually a web server, I think. Let's see. This is an APL CGI script. Okay, it's a CGI script. I think it came from GNU, somewhere on the GNU website. Yeah, it's outputs and yeah. So here is the APL source code. Let's look at it. Now APL is another language that has systematic syntax, regular syntax. So in regular syntaxes such as Lisp and APL, basically what happens is that the rules are extremely simple. Like you just learned about two or three things. It applies to the entire language, no exceptions. That is why I like regular syntax. Okay, that's one thing. So in my opinion, okay, in my own I don't like C because the syntax is almost every function has its own syntax. It's the reason you don't find it odd. Most I suppose most of you guys or any new programmer, any average programmer, you don't find any C syntax odd. They are because they are also in JavaScript, Java, Perl, uh, even in Python, almost in Ruby, you don't find it out because you are so used to. That's why. Is for the same reason you don't find English odd. But if you are Chinese learning English for the first time, you will find, oh God, it's this is total garbage. In the same way, if you are learning Chinese or Russian for the first time, or French or German, you will find it complete, garbage because it's totally irregular. You have to learn 1,000 idioms, and the grammar has 1 million special cases, things like that. So this applies to C programming language, irregular everywhere. For a computer language, it should be regular. You only learn two or three rules, and you know the entire language. You can at least you can type it correctly without syntax errors. So that's what I like. Regular syntax. Now, by the way, if you study parsers or compilers, now regular has a special meaning there. That's not what we are talking about. Okay, regular language or regular syntax in the subject matter of parsing, they have a special meaning, but that's not what we are talking about. What I'm talking about is the normal sense of the English word regular, or you can call it uniformity. Okay, no exceptions. Everywhere looks about the same. That's what I mean. So I want regular syntax. Now I want something else. Now why? Because if you have a regular syntax, then it's very difficult to do something. For example, let me show you. Okay, I have an article here. Let's go to on Lisp. Okay, and we want to find the article that is on Lisp. We want to find an article that is about operators. Okay, so let's see. Okay, here. Okay, let me magnify. So I'm going to show you some examples of the problems of regular syntax. Okay, the problems of regular syntax. Now, the one obvious example is that, for example, one obvious example is if you are coding in Lisp. Suppose I want to do what 3 plus 2 divided by 5, square root the whole thing. I mean, divided by the whole thing by 7, for example. Let's say this simple expression. In Lisp, it's very hard to read. In Lisp, this will be, for example, that 7, then that 3, then that 2, 5. Okay, this is the Lisp notation. It's regular, all right, but however, it's impossible to read. It's hard to read. Okay, so this is the one problem of regular syntax, And I show you some of the other examples of regular syntax. Like you can have variations. For example, this is another example of regular syntax. This is a normal functional notation where the operator appears in front, the function name followed by parentheses. Okay, it becomes like that. It's unreadable, hard to read. Okay, or you can write it this way. Yeah, this way. Traditional mathematical notation. Function name first, followed by parentheses, and inside the parentheses arguments separated by comma. Okay, this is traditional, hard to read. But what you really want is infix notation, or sometimes called algebraic notation, like that. But this notation is not it's not regular, because especially when you need to mix with, for example, sine, uh, you know, sine x or function, something like that, then it becomes not regular because, for example, parenthesis here is used for grouping, but the parenthesis here is not for grouping. It's functions arguments. So you have, it becomes irregular. The traditional math notation is not regular. Okay, it becomes irregular very fast, especially when you have then, for example, sine x squared. For example, sometimes people write it like that, or sometimes people write it like that, or sometimes you can write it. Normally, actually, what we really want is like that. So you have all these ambiguous cases. That's all traditional math notation. Traditional math notation is very bad. Okay, I can talk about that for an hour. I have several articles about that. They went to Hacker News now and then. Anyway, so that is the problem of regular syntax. When you have a regular syntax, often it becomes unreadable and inconvenient. That is the problem. Okay, that is the problem of regular syntax. Okay, the problem of regular syntax. Okay, and the problem is usually it becomes unreadable or inconvenient. Inconvenient. Okay, yeah, inconvenient. Such as I gave you examples. Now, how do you solve that? The way you solve that is by you can solve that. One of the way to solve that is by a syntax system. So let's copy that. Let's see. Okay, I already have that. So one way to solve that is by a syntax system. And that is what we were talking about. So okay, in order to talk about that, so okay, let me just give you a quick explanation. Okay, so for example, let's explain Mathematica. That's gonna take another 10 minutes or so. How long we been talking? 1 hour already. Okay, so we are taking a long time. So let's see what we want to do. So yeah, I'm going to explain a syntax system, basically the Mathematica syntax system that solves the regularity problem, so that you could have a syntax that's regular on one hand, 100% regular, but meanwhile also you can write it this way, so it is extremely readable and extremely flexible, but meanwhile maintain 100% regularity, meaning that you learn just you learn just a couple of rules, you understand the entire language, no exceptions whatsoever. And in fact, the syntax, once you have this system, the syntax can have so much variation. It's even more variation than Perl. Okay, for the same expression, you can write it in different ways, more different ways in Mathematica than Perl. Okay, this is true. But in order to, okay, I have, that. So I have actually I explained this many in many articles here. If you go to on Lisp index page, and I explained it in many of these articles in detail. Mathematica syntax versus Lisp. So actually, I'm not sure I'm going to explain it because it'll take a lot of time. It'll take like 10 minutes or something. Actually, I did a video, so actually check out this video because I explained the whole thing for an hour. This article, okay, XR Talk Show, 2019, July 19th. Lisp syntax, symbolic expression, meta expression, Mathematica, and meaning of sugar syntax. Yeah. So this video, it's like 90 minutes. I explained the whole thing in detail, so you might check that out. So in summary, we are talking about the problems of regular syntax, basically because it becomes unreadable or inconvenient in practice. So therefore, we solve it by creating a syntax system so that for every function or every operator. Okay, here is a 2 minutes explanation. So first of all, you are going to have a regular syntax, uh, like in this form. Okay, everything looks like this. Okay, you start with a function name. Function name can be function or any ASCII. Okay, you start with a function name, then you follow it by square brackets, then inside it is arguments. Okay, xyz or whatever, then separated by comma. Okay, now any of the argument xyz and so on is again of this form. Okay, so that is the essence of Mathematica syntax. Okay, so you can see this is 100% pure. Now let me show you an example. Now remember, every source code in Mathematica can be written this way. So it's just a function name, square brackets, and inside are arguments separated by comma, and each of the argument is again the same form. This applies for any Mathematica source code, can be written in this way. Let me show you an example. So here is an example down here. Okay, not that page, but this page here. Okay, I'm just going to show you quickly what I mean by. So here is a Mathematica function written in this form. You can see, look at this code. It's purely nested function notation, nothing else. You don't even see a symbol like plus sign or minus sign. You don't see that at all. Well, you do have minus sign and plus sign, but you get what I mean. It's just nested function notation. So this is regular. Okay, but however, how does Mathematica solve the readability problem? You see, this is not readable. It's regular, yes, but it's not readable. So the way you solve it is that for every function, for example, let me write it out. Okay, time AB. Okay, let me write plus AB. Okay, list ABC. Okay, let me just show you quickly some power. Okay, okay, and divide. Okay, list, and let's see. Okay, let's say another one equal. Okay, here are some of the functions in Mathematica. Time just means multiplication. Okay, a times b. Plus just means a plus b, or you can have a plus b plus c. Okay. Now list is just a list. Okay, ABC is a like a Python array, or JavaScript array. Power means x raised to n. Okay, these are Mathematica functions. Divide means a divided by b. Okay, equal means returns true or false, whether a equals to b or not. It returns true or false. So these are Mathematica functions. Now, what Mathematica does is that for many of these functions, it has a equivalent syntactical form. So, for example, time can be also written as that. Okay, it's syntactically equivalent, meaning that before compilers do anything at all, it just transform this form into that form. Okay, syntactically equivalent. This is important. Now, I mentioned in that video, so I talked about that in detail for 1 hour. So remember this. Most of you are familiar with the concept of sugar syntax. That is kind of abused. That phrase is abused. Like, you don't really know what it means. Like, every time you have two things that's similar, you call it sugar syntax, but it's not actually this. For example, this Mathematica, these two lines are not just sugar syntax. They are syntactically equivalent, meaning that before compiler do anything, this is transformed into that. So they are 100% exactly the same in compile time, in runtime, in whatsoever. They are just the same. They are only different to you, to your eyes. So Mathematica, for many functions, you have a alternative syntax. Different forms. So for example, for list, you can write them like this. Okay, like that. So for power, you write them like that. Okay. For divide, you write them like that. Okay. For equal, you write them like that. Okay. So for many of the functions in Mathematica, there's an equivalent form. And by the way, and any form can be mixed. So any of these can be mixed arbitrarily. For example, anytime you have this, you can replace by that, or anytime you have plus, you can replace by that. So you can so how does this work? So this works because, so when you have a syntax, so for example, let's write this in Mathematica. Okay, let's write this expression in Mathematica. So let's copy that and move it down here. So let's have, so that in Mathematica would be that. Or I can write it. Let me show you many ways to write this. Okay, so okay, that's one way to write it. Or I can write it like okay, I can write like that. Or I can for example, go further like that. Or I can remove part of it, like I mean, not remove, I mean like that. Okay, and I can or I can write it like this. Okay, Okay, so all these 5 lines are equivalent. You see, now you get to see how it works. So this is Mathematica. Okay, so this way you still have regularity because in Mathematica you can press a button because they so it come back to grammar because the syntax, the equivalents, they are all well defined. So that's what I'm saying. The grammar itself has a grammar and it's very simple. It's all regular. So you can easily transform any one of these to the fully let me try another one to the full notation. Okay, plus. Okay, then we can write this as divide 2 5. Okay, okay, now you see the complete full form, the complete nested form. So it can transform, so any of these can be transformed easily, trivially to this form. Then you have, then it's regular, it's regularity. In fact, this is whenever you do pattern matching or symbolic, pattern matching, symbolic pattern matching in Mathematica, it works based on this form, which is like list macros. So anyway, so that's a lot of talk. So you see what I'm saying? I guess I hope I'm not getting boring here. Uh, so in summary, the syntax I like is regular syntax. Uniform, no exceptions. So you only learn a few things, and you know the entire language, no exceptions, whatever. And the opposite extreme would be C, C plus plus, those kind of C syntax, where almost every function has its own special syntax. It's like bizarre, idiotic to the extreme. So I like regular syntax. You just learn a few things, and you just learn like 2 or 3 rules. You understand the entire language's syntax. But also, once you have a regular syntax, you may have a problem where it's not practical. It's unreadable, such as this. When you see this line, it's regular, but it's unreadable. You rather want to see it like that. So how do you solve that? So you can solve that by a systematic syntax system. So that's what I mean by saying that Mathematica has a systematic syntax system. Okay. Let me so we can show this in browser. Okay, show in browser. So that's what I mean by a syntax system. So that is the syntax I like. Okay, I like that syntax. Now we have just explained Mathematica's syntax system, but however, this is not necessarily the only one. You could have you could easily have another syntax system that is regular, but looks very different from Mathematica. So I'm saying this because I don't want to get the impression that, oh, I'm just a fan of Mathematica. No, rather I want to emphasize that what it so happens, Mathematica is my first language and I love it. But the idea of syntax system is not necessarily just Mathematica. For example, you can, if you go to syntax soup, read these first 6 articles. For example, on constructed, they are all related. On this article on constructed languages, computer languages, and their grammar complexity. You can see similar ideas where I talk about the grammar complexity of C and C++ is astronomical. It's like a huge number. On the other hand, the grammar complexity of Lisp or APL or Mathematica will be very low. You know, so that's about this article. So let's look at the next article. Composable syntax. Okay, when you have a regular syntax such as Lisp, APL, or Mathematica, then the syntax is composable. Like you only learn a few things and you just combine them together. Which is not the case for C. For C, C++, for example, some are operators, some are statements, some are expressions, and some are pragma. Like in Perl, you have pragma. Like you cannot mix them together. You have to learn 100 rules, 100 exceptions. Okay, that's the idea. Composable syntax. So this is almost like the idea of functional programming. You compose functions on you know if you apply that to syntax, then that's the idea of regular syntax. You compose things together. Once you know one rule, it applies to the whole language. Then it comes to syntax algebra, and then we come to the concept of formal languages. This article is from what you see here. It looks very fancy. It came from this article. Okay, a Galois connection calculus for abstract interpretation. It's about mathematical logic, something like that. I don't understand. Okay, so abstract. It says we introduce a Galois connection calculus for language independent specification of abstract interpretation used in programming language semantics, formal verification, and static analysis. Okay, it's very advanced. I don't understand. So I think Justin, you would like that. It's Haskell. It's related to Haskell. So anyway, you can see that it's all it's all very fancy math. It looks like math, fancy math. But however, the way when I see this, I'm thinking of composable syntax. That's what I'm thinking. Composable syntax. So this comes to the idea of formal languages. It's all about syntax, where that's so one day with languages like this. Okay, with language like this, you almost it's almost like you are not concerned about semantics anymore. All you are concerned about is syntax. You just compose. You just put them together, compose the syntax. And the syntax almost like they don't have a meaning anymore. However, they can do proofs. It's the idea of formal languages. Okay, I think that's about that. That I explained about the systematic language, the syntax I like. Okay, so are there any questions about this? Ask me now, and we'll be done. Yeah, we'll be done in 2 minutes or 5 minutes. So I used to think X expression is similar to this, but convince me not. Yeah. So let's see what are the comments. I'm getting tired. I need a drink. So today's drink is this energy drink. And how am I doing? I think I have a articulation problem. Yesterday Israel is accusing me. Well, he's saying my English. I have a lousy command of English. Actually, the problem is not my English. Actually, it's just me, the person. Because when I talk in Chinese, it's the same thing. Where you just see ramblings, incoherent rambling, and sometimes stuttering, and it's the same when I talk in Chinese too. I grew up with Chinese, right? So it's the same with Chinese. So the problem is not my English, my command of English. Rather, it just is some sort of it's just being a schizoid or something. I don't know exactly what it is, but that's a problem. And that is also my sour point, because I always thought I wanted to be someone with perfect English, like no accent, like New Jersey accent, the standard broadcast accent, no accent. And I want to be this perfect guy who can articulate so well and extremely logical. but but now I've seen my own videos, that it's like no way, no way. I talk so bad, uh, but that's something actually I can improve if I really want to. You just have to practice on that. Okay, so let me read the comments, and that'll be it for today, for a few minutes. 3 more minutes, something like that. We'll be done. So let me read the comments. Yeah, that's a huge garbage truck. So Elixir has great syntax, and Elixir is a great improvement over Erlang. Yeah, Erlang syntax is pretty weird. Maxerator. Who asked the question? Maxerator. Oh, Informatic. Informatic, are you still here? So Informatic question is, I'm wondering what operating system will you use if I didn't get my Mac for free. Okay, well, that it will probably, I was going to say it will probably be a Mac. If I have, if I can choose, if I have money. Yeah. I've been using Mac, from 1991 to 2008. Okay, basically among Windows and Mac and Linux, Mac is just the best. It really is the best by far. The second best is Windows. Linux is truly the worst. Unless you put qualifications such as if you are a programmer, for Ruby, Python, um, Emac Lisp, then Linux is the best. Okay, I mean, if you are open source developer, then all you do every day is programming, okay, then Linux is the best, no question about that. But if you use it for a desktop, sometimes you want to play music, sometimes you want to Skype to your friends or video chat or whatever, or compose music. Linux is the worst shit. It's by far, not just it's like by a magnitude. Fuck. But if I have money, I can choose one. I was going to say to be Mac, but I'm not too sure, because they all have problems. They all have lots of problems. On Mac, like today, Mac, Apple is so evil. They make your phone slower on purpose every time they have a new phone, things like that. And also on Mac, they they make your CPU slow intentionally, because that way, because they don't want the fan to turn on. Okay, because if you go to YouTube, there are people talking about that in detail. I think Linus talked about that. Yeah, Linus, the guy very popular doing hardware reviews and so on. They so I learned the Mac, they don't want the fan to go on, because whenever the fan go on, people don't like it. So they for PR, public relations, they don't do that. How they but how do they avoid the CPU heating up? They avoid that by slowing the CPU down. They actually do that. They slow it down. They don't, and so meanwhile they can say, "Oh, this is running I call whatever the late Intel I call 7 or I call 9 or I call 1000." Okay, but so they are running the latest fastest CPU, but meanwhile they actually slow it down, so the fan don't come up, and the consequent result is that it's actually slower. When you use a Windows machine, that's not even with a previous generation of CPU, it's faster than the Mac. Anyway, so Apple do all these kind of things because their goal is just to make money. But on the other hand, if I go by Windows, so I don't want Mac. I really don't want to use a Mac because I don't want the company. On the other hand, if I go to Linux, yeah, then I don't worry about this corporate, greediness problem. But then every day you spend 1 hour fucking this, research that, go to Arc Linux, go to Wiki, it's a headache. On the other hand, Windows is kind of in the middle. But they have privacy issues. And then you have to worry about virus. Okay, now Windows has a lot of virus, not because Windows is not secure. Okay, Linux is far worse. If you actually think about it, it's far worse. The reason Linux don't have much virus is because those who write viruses, they don't write for Linux. They write for Windows, because every time you spend time to write a virus, for each Linux user, you have 1,000, 10,000 Windows users. Obviously, you want to write virus for Windows. You don't want, because there's no, you want more bang for the buck. That is why Windows has more virus. Not because Linux is secure my ass. Linux is actually worse, in my opinion, less secure than Windows. Okay, but anyway, so if I go to Windows, then I have to worry about virus. Then there's Microsoft. He's trying to take your data by all chance possible. On the surface they provide you options to turn it off, but in reality you have to go very very hard. Okay, so that's a problem. So Linux, Mac, Windows, they all got problems. In fact, it's like that since 1990s. I mean, I talked about this in one of my articles. If you search for Xali, search for the article Xali switch Mac to Windows, you'll find it. Okay, the situation has been the same for the past 30 years. On a Mac, it's more expensive. You pay twice the money. Okay, uh, and everything is nice. Everything is nice. What just things just works. But Apple sucks your blood. On Linux, you don't have to pay. It's the cheapest possible. You don't have to pay. But every day it sucks your blood. You have to spend every day, every week, let's say 3 hours every week, spending on dealing with Linux, fixing things. Why something doesn't install? Oh, you don't have something doesn't. You need to update the driver. This or that. Fuck. First of all, you have to spend 10 years to be a nerd before you can actually use Linux. And on Windows, you have the virus problem, and you have Microsoft's suck problem. And by the way, on a Mac, it's most, if you are concerned about privacy, Mac seems to be the best. And even on Linux today, you have Ubuntu. They have all kind of crap, learning. Anyway, that's about that. Informatic. I hope that answered that question. I don't know if you are still here. Okay, so okay, I'm getting tired. I don't know. Let me just answer the questions addressed to me. Uh, Bartholomew says, how easy is it for a math-loving person to learn Mathematica? It's pretty easy without knowing computer science or another programming language. Oh, that's so easy. Mathematica, depending on how deep you want to go. Most vast majority of Mathematica users, they are simply using it as a calculator, like a graphing calculator. So you want to solve integrals, you just type it, then it gives you the answer. You want to get derivatives or you solve linear equations or differential equations, just type it. It gives you the answer. So that's actually majority of Mathematica users are using it as a like a graphing calculator. Now for you, Bartholomew, you are kind of in between the computer science and media, right? So Mathematica is actually very good for you. So you can use it as a scientific, like a graphing calculator. You almost you don't have to learn anything. Just follow, just type things and you give you the answers and graph, and you can rotate it. You can also change parameters. Then the graph will change in real time, things like that. But if you want to dive deeper, you want to start it to learn how to program it or how the like the syntax I've been talking about, you can. So that's when you start to dive into programming Mathematica. And depending on how far you want to go, you can spend you can yeah, it depends on how what kind of expertise or mastery you want to go. You can be like me, spend 10 years in it. I spent like 2 years in it. So, and I wrote a program back in 1994 to do plane curves. So I got hired. I went to work for Wufan. So depends on how much you wanna, how far you want to go. So okay, I think that's it for that. Uh, what about Debian 10? Hyder TV, good morning. Have not seen you before. You are new here. So what about Debian 10? What do you mean? Debian was the Richard Stallman approved system in the beginning. But I never used Debian. So is there something special about Debian 10? Uh, Debian. Debian is like Linux is open source, right? They and so they don't have money, and even so Ubuntu is the most popular, and it sucks so bad, when when it becomes popular, it just like everything that sucks, like it becomes like Windows. Like you install Ubuntu, then you have this software, what they call software store, just like Windows Store, Chromebook, Google's Android, store, Chrome Store, and Apple Store. They start to have this store. Then you search programs, then it comes up or like 99% is garbage. For example, I'm a Linux user, right? I'm an open source fanatic. Okay, I'm a Emacs fanatic. So I want to, for example, let me show you. Okay, so let's say Linux. Okay, so I'm new to Linux back in 2011 or something like that. It's my first time where I use Linux as my desktop every day. Okay, I was system admin for Solaris back in 1998. So those of you who want to say I don't know Unix, shut up. Okay. So anyway, I was using Linux as my desktop in 2011, first time as my desktop, and so I wanted to know, okay, what are some of the music programs I can use, or some, let's say image programs, image viewers. Okay, I want to know what are the some of the image viewers I can use. So for example, I have written down all my experiences here. Image viewers. So this page I give you a introduction, my research. I tell you what's out there. So you have gthumb, which is from big with lots of features and slow. Okay, you have Eye of the Gnome, you have KDE stuff, Grand View, that which is default in KDE back then at least. They change all the time. This thing. Then GQ view, you have LXD, GPIC view. Then you have the Ristretto from XFCE. Okay, anyway, so that's my survey of image viewers. This is a natural question, right? If you are using some operating system, you want to know what's the best. But on Ubuntu, you have this app store, just like fucking Windows app store. You go there, then the bunch of ads, whatever. Oh, fucking ads, for the normal people. Then if you type image viewer, you have like 100 irrelevant fucks, like for the image viewer for the non-technical users or something. Basically, no good. Basically, then they started to Ubuntu back then a few years ago, they started to do all this storage. Yeah, they are trying to copy because remember we have what's Google have Google Drive, right? Before Google Drive you have that what's the other one, some box Dropbox. Okay, so Ubuntu is trying to do that too. Then 2 years ago or so 3 years ago they failed. Like open source, they are trying to squeeze money. You don't make money. They try to. How did Ubuntu begin? Let me tell you. Okay, it began by this rich guy from Africa. Why is he rich? He is rich because he became rich because he was selling certificates. Okay, certificates. The HTTPS SSL certificates. What's the company? VeriSign. It was VeriSign back then, I think. He sold it. Then he started Ubuntu. Okay, so that's a basic story. And and Ubuntu. Oh yeah, Ubuntu. I remember. Yeah, they started to call their drive, I think, OneDrive or something, like a software service. Because with open source you cannot make money, so you go to the cloud servers. And I remember using it. It sucks so bad. It's like impossible to believe. Impossible. It's impossible to believe. It sucks so bad. Then eventually, they killed it, and they have lots of other stuff. Ideas like that. That's a story of open source. Another rant, I guess. So that's it for today. Good morning, meow. Good morning, meow cats. Browser is your image viewer. Yeah, so Linux is good for, what is Linux good for? Linux is good for nerds, for those of you who are programmers or those of you who are into technology. Then it's really good because you also learn it. But it's not, when anyway, when most Linux fanatics, they say, "Oh, Linux is better than Windows." That's total bullshit. They forgot to add the qualification. If they say, "Yeah, Linux is better than Windows," if you are a programmer, or if you are interested in programming, or if you are a tech head, you really are interested in CPU and how things work. Yeah, it is better than Windows for sure. Because every time you spend to learn these partitions, or the booting steps, the bootloader or whatever, or the kernel, what is the kernel, what is the fucking driver, what is this, that, the key binding systems, what is X11, the windowing systems. Yeah, you learn it. That's because you want to. But your mom, for each one of you who are into programming technology in Linux, there are 1 million who are not interested. Most people, they cannot use Linux. So when you compare which one sucks, you have to consider that. Not or if you yeah, you have to put into context. That's a thing. Good morning, Kathy. Matt. Yeah, exactly. So Matt says for people who just want to get stuff done, I would not recommend Linux. I have both Windows and Linux. Okay, that's it for today because then this is gonna be a infinite talk. We mostly we are talking about syntax. Okay, thank you guys for watching. And if you like my stuff, subscribe if you have not already. Subscribe and click the bell. The YouTube. Everyone is and put money in my pocket. Okay, I have PayPal and Patreon and stuff. put put money there. A Discord. Yeah, Discord is actually I forgot what it's kind of a social network like Twitter. Wolfface. Good morning, Wolfface. Okay, bye guys. Tomorrow 9 o'clock. Okay, same time for this week. 2 more days.